Good afternoon, everybody on Fiveable. Yes, I'm so excited to continue our Cram sessions for AP Statistics. I hope you all had a great week. If you're in the Southeast, I hope you were safe from the storms yesterday. We had kind of a crazy day here in Alabama. We were out of school and just spent all day watching the weather. And luckily nothing happened close to me, but there were some areas around not too far from me that had some storm damage. So I hope that doesn't include any of you. I hope you're all safe. If you're in like the Georgia, Carolina area, I know that y'all maybe kind of catching the tail end of that today. So today what we're going to be looking at is collecting data. Usually one of those chapters that either you really like or you really don't like. It's just kind of one of those that some people really like it because they can see how it check. Hopefully, okay, I'm seeing audio on my end again now. Hopefully that's better for you. My microphone is just not wanting to cooperate very well. And it quit working on captions as well. I'll work on that. All right, hopefully that is fixed for the audio. Like I said, my microphone is just not wanting to work. So let's see here. Let me get my captions back up. I will go to that. All right, so there we go, and hopefully we're back. Chat, yes, we can hear you. Okay, awesome. All right, so anyways, yeah, so trivia tomorrow night. This is a great chapter to take advantage of the trivia option because it is a lot of just factual knowledge, not necessarily calculating and practicing procedures. It's more so being able to read about a study and determine different definitional things like that. So the Unit 3 trivia, to me, is probably one of the most important trivia sessions that we will have over the course of the semester. So take advantage of that. And then, of course, the 5-hour cram finale. I mean, that's where the money's at, like that's where you're really going to hone in on those ideas that you're still unsure of the day before the exam, and that's on the day before the exam. So on this stream, trying to sum up everything that we have for this particular unit, we're going to talk about how you would go about planning a study. We are going to talk about random sampling, making sure that we are creating a random sample. That is super, super important, and there's nothing we can do to fix that when we miss that. We're going to look at bias and other types of problems with data collection. And then lastly, we're going to look at experimental design. So there's two types of studies we can do, one being an observational study and one being an experiment or experimental study. And they are very different in the way they are approached, and they definitely, experimental studies have very important aspects to them. So we're going to look at those. All right, so the first thing is when we are planning a study. So if I'm doing a statistical study of some sort, just in general, okay? any statistical study in general, what is the goal of that study? So put your ideas in the chat. What is the goal of your study? Any type of study. Could be observational or experimental in this case. What is your goal that you're trying to do? I'll type it out so you can see. Okay, so finding an explanation, that is true. Figure something out. Okay, ultimately, that is what we're trying to do there. Identify a numerical value of significance. Gather data. Find something out. Come to the conclusion of a certain opinion. So, I see the Anika, gather data. What do you want to do with that data? So you gather data about a group of people. So then what do you do with that data? You analyze it and you come up with a result. But then what? All right, I'm going to give you a little bit of a hint here with a little picture. Okay. Conclude, that's a good word. We want to conclude something about the Yes, we want to conclude about a population. Okay, so for instance, if we're looking at U.S. adults, all right, and we want to make a conclusion about how a certain behavior of all U.S. adults. I can't observe or apply a treatment to the whole U.S. adult population. It's just not feasible. Okay, but what I can do, and you can see that over here, is I can take a sample out of my population, okay, and I can use my data for my sample that in turn I can generalize to the population, which is exactly what Sarah said. That is a super important aspect of statistics. That essentially is what statistics is you're taking a smaller picture sample, all right, that's your little picture, and you're analyzing some data, you're doing some calculations, and then you want to be able to take that sample and that conclusion that you find and generalize it to a much bigger picture, which is your population. Okay, so that is our goal. And it's a lot of times very important to be able to determine in AP statistics or any type of statistics what exactly your sample or your population is. Okay, so again, the population is the big picture. And a lot of times we're trying to estimate what the population parameter is, either the mean or the proportion of the population. And what we use to do that is a sample statistic. Getting a little bit ahead of ourselves in terms of the content, but we take a sample statistic, a mean or proportion from the sample, and we use that data to generalize it to estimate a population proportion. So S, sample statistic, P, population parameter. All right. So a little exercise here. We are going to look and see if we can determine what is the sample and what is the population from this given setup here. Okay, So a random sample of 40 chameleons is taken from a chameleon colony to take their weight to estimate the weight of all chameleons. Okay, so the first group we have here is chameleons from this colony. Is that a sample, population, or is that neither for this particular? Okay. Ooh, this one's interesting here. We got some conflicting responses. Okay. So here's what we got. We have I don't know why it's not showing up for you guys. I hit publish and it seems to be taking a long time. We have a mix here. So we have some people say population, 3 people said population, 2 people said sample, and 1 person said neither. In this case, that is going to be your population. All right? That is what you are trying to generalize, and actually what you could generalize your results to be. All right, I can't generalize the results from one colony to every group there is. Okay, so the next set, the 40 chameleons in our sample. Is that the sample, the population, or neither? Okay, think about that one. Yes, this one is the sample. Okay, good job there. Everybody got that one correct. So yeah, so we have a random sample of 40 chameleons. That one's kind of obvious. It kind of gives it to you. And then what we want to do is we want to use the weight of those 40 chameleons to estimate what the weight is of all the chameleons within that colony. All right, now all chameleons in the world, we cannot generalize our results from our random sample of 40 to all chameleons into the world. We can't do it. There may be different environmental factors that are affecting this colony that's not affecting the other colonies throughout the world. So that one it's beyond our scope of inference. I can't make a generalization from this one random sample from one colony to all chameleons in the world. So that one would have been neither. Okay, so let's look at the next example here. All right, a random sample of 75 high schoolers from Hawkins Middle School is asked if they want to join AV Club. I hope some of you catch the reference here. I really hope you do. So our first one is 75 middle schoolers surveyed. Is that our sample or is that our population? Yes, that is our sample. Whoop, whoop. Good job, guys. Good job. So the next one is all middle school students. Okay. All middle school students. So what do you think? Sample, population. I forgot to put neither on the last one. Or neither. All right, looks like we're in good shape here. All right. Most people said neither, okay, but there were a few who said population. All right, now in this case, it doesn't say all middle school students from Hawkins Middle School. So your random sample has to be taken directly out of your population. So in this case, our random sample was taken from middle school students at Hawkins Middle School. So your population is the group in which your sample was drawn out from, which in this case is all middle school students at Hawkins Middle School. So our population, whatever we were generalized here, okay, I could not take my results from my sample of 75 and generalize it to all high school students in the U.S. or in the world or whatever, or middle school students. But I can generalize it to Hawkins Middle School. Okay, their AV club is obviously pretty cool. I mean, they enter like extra dimensions and stuff. We didn't even have an AV club at my high school, but if we did, I don't think we would have been, battling demogorgons and all that cool stuff. So I would have been a lot more likely to join the AV club at Hawkins Middle School than at the AV club at, Bob Jones Middle School or whatever. So in that case, I can't generalize my results from 75 middle schoolers at Hawkins to all middle school students, but I can generalize it to just that one school, since my sample was only taken from that one school. Okay, that's a very important concept. It does show up a lot in the multiple choice section. I just saw your the comment there in the chat. So the second option, I was thinking all middle school students in the world, just general broad scope. I think the AP Stats exam would do a better job at making it clear which one, if you saw these three options, I think then it would be clear which one is the sample and which one's the population. And the fact that all middle school students is neither. It's too broad of a scope of inference for our little 75 sample from Hawkins. Okay, so moving on, the next thing is what I call the golden rule of statistics. I tell my students, you have to know this. It is super important. It will show up on the AP exam in some form or fashion. It shows up on the free response very often. It also shows up on multiple choice pretty often as well. All right, and I call it the golden rule of statistics. And that is making the distinction between an observational study and an experiment. Okay, that is super, super important. Because somebody wants to put in the chat, what is the big difference in these two things? What is the difference in an observational study and experiment? Okay, treatment versus no treatment. Close. You're not doing anything to the sample. Also good. Correlation and causation is definitely going to come into play. Experiment deals with cause and effect, and observational study does not. But how in my setting up the study can I make it so that it's an experiment versus making it an observational study? RA was very close there in the chat. On the right track, at least. I need a little bit more. All right. So an observational study is one in which the researcher is observing pre-existing behavior by something such as maybe a survey. Those are good studies for certain criteria. However, in an observational study, as we mentioned, SP, several of y'all on the chat have mentioned this, causation cannot be determined in an observational study. Sometimes that's the best we can do in terms of setting up our study, but you cannot say that one variable causes the other. Manipulating the variables, that is exactly right. An experiment is one in which the researcher interferes with the subjects. So the researcher is randomly assigning treatments. Those are the three key words for an experimental study or an experiment. Due to that random assignment of treatments, the end results can establish causation, which makes an experiment a stronger type of study. Okay, because we now have that X causes Y, which is a pretty big deal in the science world. Whereas observational study, you might say X is correlated with Y, and then you can further investigate things. So that is definitely something you need to know. I think it was, oh gosh, what year are we at? 2021. So 2019, the last regular exam there was a free response question that was, that was part A. Is this an observational study or experiment? And determine which it was. My students that I had at the time, I was like, you've got to know this. And since then, I've adopted the terminology, the golden rule of statistics. It also showed up a lot on people's exams last year. Of course, everybody got different exams, but it was very common to show up for people. So it is definitely something you need to be able to determine. It's also great to write out that if something is an experiment, that you can establish causation, as y'all talked about in the chat, or if it's not an experiment, then you cannot establish causation. Okay, I'm going to go back real quick. Thought there was another line there, but I guess that's it. So make sure, guys, that you are familiar with that. So this little chart here kind of sums up everything. So it's very important that you, number one, take a random sample. So by taking a random sample, you can generalize your results to the population. Okay, if I take a random sample of Hawkins, Indiana middle school students, I can generalize my results to all Hawkins middle school students. However, if I only took a sample from students who were maybe in my class, okay, then I can only generalize it to the subject area in which I taught, which may be some AP science that would cause them to be more interested in the AV club, if we're going back to that example or whatever. So, but if I just randomly select, 25 students or 50 students or whatever, and use that as my sample, then I can generalize those results to my population. If you don't have a random sample, you cannot generalize it to the population. And in all honesty, your study is kind of garbage if you didn't take a random sample. There are times where a convenient sample is necessary because that's all you can really do. Or, obviously things like a census where you are able to ask everybody is great too. But if you're taking a sample and it's not randomized in some way, pretty much your study is garbage. There's not much you can do to really save it either. your results are going to be biased more than likely. So that is one aspect of randomness that is important. Did you take a random sample? Yes or no? Can you generalize to the population? Yes or no? Then the other aspect is that experimental aspect. Is it an experiment or not? So random assignment, then you can establish causation. So if you take a random sample of 50 participants and then you randomly assign 25 to treatment A and 25 to treatment B, so two types of randomization, then you can generalize it to your whole broad scope population, and cause and effect can be established, which is obviously the best type of study you could have. So then if you do not randomly assign it, then you cannot establish causation, but you can establish maybe correlation, which definitely means you want to investigate further. So an example of this, kind of an interesting story. Earlier this week in my AP Stats class, and I really wished I could have recorded this meeting. My computer ran out of space in the middle, and like 5 minutes in, and then it quit recording the Zoom meeting. We spoke with a doctor from University of Alabama at Birmingham, who is an infectious disease doctor, and we talked about how statistics has been used in the COVID vaccine trials. And one of the studies that he ended up bringing up, he's in the past works with HIV patients. And one of the studies that he mentioned is he said that they were realizing that there was a much higher death rate among their patients of color. They're mainly African American patients. And they noticed that correlation, and they said, what can we do to make this better? And initially they thought this is some sort of genetic difference that just makes this group more prone to a serious illness. And they said that through statistics, they were able to analyze a little bit further and found that the real part of the data that was causing a higher death rate had nothing to do with race. It had everything to do with missed visits at the clinic. So by investigating that a little bit further, so they found that it appeared like race was correlated with the death rate. But instead of giving up, they dug a little bit further and found that maybe the race was causing the missed doctor visits, and the death rate had everything to do with the missed visits and nothing to do with race. And that gave them something they could actually work on. So in statistics, and we'll get to this in a minute, we would call that a confounding variable. It was something that was happening and causing the result, but it wasn't the variable we were really interested in. And now they really hone in on patients at their HIV clinic who are missing visits. So I thought it was really fascinating. You had that correlation, couldn't establish causation because there was no interference of you miss visits and you don't miss visits. And even if you were setting up that study, that is totally unethical. You can't tell one group of patients to come to all their visits at the doctor and one group to miss their appointments. The International Review Board would give you a hard pass on that and probably would question every bit of ethics you've ever done before. So in that case, an experiment doesn't make sense. But an observational study was good, and they were able to fix that. So anyways, I thought about that. That's an example of a study that you could not randomly assign treatments. It doesn't make sense, and the data was still there to give the correlation in which they were able to solve that problem with their patients. Why do you need random assignment for causation? Because by randomly assigning, you are making sure that both groups are created equally and there's nothing else going on. If you just assign them and just say, this group go here and this group go here, then that's not good enough. They have to be randomly assigned so that any differences among your sample is randomly split up evenly. And then when you do that, you have a much stronger, it's like a stronger correlation in a sense that establishes causation. And Sandra, if you have a better answer for that question, I feel like I kind of danced around the answer on that one. If you have a better answer you want to put in the chat, that would be fantastic. I just know that's, it's one of those things that kind of too, like that's just the rule, like random assignment strengthens your study, therefore you can establish causation. You can generalize to a population if it is a random sample drawn from the population. So going back to our slide here, if I take out of my population of 100,000 people and I draw a sample of 100, I can use the data from my sample of 100 to generalize about my population of 100,000, even though I did not randomly assign them treatment A and treatment B. But I can still gather that correlation, and I can generalize it to everybody because they were randomly selected from a much larger group. But since they weren't assigned treatments, I can't. Since they weren't randomly assigned treatments, I cannot establish causation there. Okay, this chart is a great thing to study. It shows you both random elements in a study and what both of them mean. Random sample, can you generalize to a population? Random assignment, can you establish causation? That's that golden rule, experiment versus observational study. All right, so the next thing is, so we've kind of talked about why randomization is important, both in assigning treatments and in selecting your sample. So then the next thing is, how exactly do we randomize? This is a really popular topic as well. So there are a few popular and also acceptable ways to the College Board on how you can describe a randomization process. So there's the hat method, which is the one I personally use most of the time. So when I kind of teach more. There's random number generators, and there's a random digit table. There's other options as well. So what I want to do first of all, before we kind of dig into some examples and what's important with these, is I want you guys to answer which of these three processes do you use? Do you prefer the hat method? Names in a hat, I guess, is maybe a little bit more clear. A random number generator or a random digit table. There's also flipping coin methods too. You can put that in the chat if there's another method that's not one of these three that you can use or that you've used. All right. Mostly random number generator is what it looks like. I feel like my students prefer that method more. I've noticed that this year, even though I sort of taught all three, but I usually gravitate to the hat method if I'm explaining a problem. I've noticed that my students seem to gravitate towards the random number generator, so that is interesting. Okay, so excuse me. Looks like most people are on the random number generator train. So we will kind of look at that. So the hat method, if you were to use that, basically what you do is you're going to assign all members of the population's names. So you get a spreadsheet of all the people in the population, and you assign them a random number 1 through n. So person 1 is 1, person 2 is 2, person 3 is 3, all the way down to capital N, which is your population size. You put the numbers in a hat. Okay, big part here. You have to mix them up. Shake the hat. Put your hand, shake it up somehow. All right, and then you're going to draw out N participants. Okay, so if I want my sample size to be 100, I'm going to draw out 100 sheets of paper. Those 100 numbers match to my 100 people I want for my random sample. Make sure that you mix them up. I really like the giving them a random number as opposed to just writing their name on a sheet of paper, because you could have someone with a really long or really short name, and that could create some bias in terms of the physical aspect of pulling the paper out. So numbering it eliminates most of that bias. But the big thing here is you have to mix them up. That's where that randomization comes in. You're not drawing the name off the top. Kind of like a lottery ball randomization there. All right. The random number generator, which is the one most of you prefer, requires you to assign all population members a random number 1 through n the same way. Then use a random number generator to generate lowercase n numbers. Again, you have a population of 1,000 and you want to select a sample of 50. Everybody gets a number 1 through 1,000. You use a random number generator to generate 50 numbers. Important part for that explanation is that you're going to skip repeats. And then you're going to use those individuals as your random sample. There's a random number generator built into your graphing calculator, which we'll get into using probably on Monday night at the next stream. I'll pull up my calculator and we'll work with that. And it's a very similar process, okay? Very similar way of breaking things out. And the other method is a random digits table. With a random digits table, you need to be sure that you number your participants with the same number of digits. So if you have 1,000 people in your population, everybody needs to get a 4-digit number. If you have a 2-person population or a 90-person population, everybody needs to get a 2-digit number. So they may start at 01, 02, 03. You might even start at 00. Okay. As long as the way that you detail that out in your explanation just needs to be consistent. So if there's 90 people and you number them 00 to 89, that would work. Or 01 to 90 would also work. And then 00 you would just skip. So again, you skip repeats. You got to make sure your placeholders are correct. Whatever your place is on that, 1,000. You need every individual needs to have 4 digits in their random number they're given before you select those out. Okay. You do not have to explain each of those. You really just have to know one and stick with one and go with that every time. All 3 of these are acceptable. There's also like a coin method that I've seen people do, and they put it on the answer keys sometime. That just seems a bit too complicated for me. I really like the first 2 the most. Random digit table is just a little bit trickier to do. I like random number generator or the hat method, which most of you did as well. So all of those are going to create an SRS, or a simple random sample. And again, you don't have to know each one individually. Just know one and be able to go with one really well. So some other types of sampling that are a little bit better. A stratified random sample. So what a stratified random sample is when you break your population up into meaningful groups. And then you select a simple random sample from each of those groups. And then the combination of all of those smaller SRSs make up our stratified random sample. The best example I can think of for stratified, yes, capital N is the sample size there. Sorry, I just saw that on the chat. The best example for a stratified random sample that I can think of is separating M&Ms. So you get a big bag of M&Ms and you separate them all by color. And then you take a sample of 2 from each of the color groups. Now you have a random sample of 10, and each color is equally represented. So that is a stratified random sample. You separated them into meaningful groups by color, and then you took a small sample from each of those colors. All right, kind of on the flip side of that is a cluster sample. So on a cluster sample, you break up your population into non-meaningful groups. So in this case, if you're going back with M&Ms, fun size M&Ms bags. And then you take one group, and that one group is your cluster sample. So if I have a big bag of M&Ms, I might just shake a few into 10 cups. So I sort of pseudo evenly break up my big bag of M&Ms into 10 cups. And then my cluster sample is just pick one cup. And every M&M in that cup is my sample. Okay, I'm not taking one from each cup. I'm just taking that one whole cup as my cluster sample. So stratified, separate them into meaningful groups, take a little bit from each cup, cluster sample, you randomly pour a little bit into each cup and pull one of your cups. Okay. That's one of those things too, just studying those vocab words is going to be important. Also, a systematic random sample, an example of that is like put everybody in alphabetical order and every fifth person on the list is chosen. And that's a random sample, and but it has kind of a system to it. Also, a census is all subjects in the population are part of your sample. So your sample is equal to your population. Very hard to do, not very common. That's why we call the census, we do every 10 years, the census, because the goal is to ask every single resident of the United States. So in terms of meaningful groups, think about it as homogeneous groups versus heterogeneous groups. Are you putting them into groups where it's everything with everything that it's alike, or are you putting it into groups that are everything's kind of randomly different? So color, those are homogeneous groups. All the blues are in one cup. All the yellows are in one cup. All the browns in one cup. Whereas fun size M&M's bags, it's in there with a bunch of things that are different from it. Okay. So bias. I love this little graphic here. Okay, we hear so much about bias in our world today, and this graphic just speaks volumes here. Okay, so you have two axes. You have the bias, so things to the left versus things to the right. I think I did my hands backwards there. Things to the left, things to the right. Anyways, the mirror image throws me off. And then so that's the x-axis. The y-axis is how reliable are things. So clearly where you want to be is at the top of your chart, because you want to be getting reliable news. And you also and you see that the most reliable is the one that is not biased as much. It's in the middle. So it has a bias score of 0. It doesn't go one way or the other. My favorite thing about this graphic here, and there's several versions of this, I have seen one where the Weather Channel is at the top. I just think that's funny that they have to put the Weather Channel as not having political bias, and hopefully they are factual. Also, I love the National Enquirer down here. They're not biased, but they're also just not reliable. It's a tabloid. So it's totally, there's nothing really good about it, just the entertainment value. Okay, it's not biased, it's also not reliable. So anyways, that just kind of cracks me up a little bit. So yeah, so we're familiar with the word bias. Is it leaning one way or the other? So multiple types of bias you can have. You can have a type of sampling bias, which is when there's something biased in the way that you took your sample. You could have a voluntary response bias, meaning you only took volunteers. Clearly that's going to cause things to be off if you only chose volunteers. You can have undercoverage bias. That is when you leave out a particular group. That could happen in the M&M example if you did a cluster sample. You might not get any blue M&Ms. You might dump a little bit in 5 cups and then pull one of your cups, and you get a cup that's all brown, orange, and yellow. No green and no blue. So those two groups would be undercovered in our sample there. Non-response bias, that is when somebody in your sample just doesn't respond. Okay, a volunteer, you take volunteers for a survey, sometimes they don't respond. Convenient sampling bias also happens. If you only ask the people who come through the front door of the school instead of the front and back door and the gym door, then it's a convenient sample, but it also might introduce some bias, especially if the front door is maybe by the lunchroom and that's their first stop for the day. There are types of non-sampling bias. So this is bias that is introduced by something that doesn't have to do with the way your sample was brought up. You have response bias. That could be when the person that is collecting the data creates some sort of bias in how they respond. So for instance, if a police officer asks you if you've ever driven too fast. Okay, now we know the answer to that question is probably yes if you're at a driving age. But if a police officer is asking that question, you might be a little bit more prone to say, no, not really. Even though, last Friday night you were hanging out with your friends and decided to see how fast your car would go. Don't do that. Don't recommend that at all. We care about you way too much here at Fivable. But you would be way more prone to answer to a police officer with, no, I've never driven my car 20 miles over the speed limit. Whereas in reality, you might have. So that creates a response bias. Also, it could be question wording bias, which is kind of the same thing. It's when the question is worded in a way that creates a premeditated response. It is almost like a rhetorical question. Like the question's asked, and there's only one acceptable way for you to answer that question. And that happens all the time, especially when we go back to that political bias discussion. I see studies on social media all the time, in which the questions are worded in a way that any decent human being would only respond to option A, when in reality, that's just biasing your data. You're getting survey results that are super biased and not reliable. So yeah, those are types of bias that can be introduced. Experimental design, it has the following 4 elements. These are the 4 big things for designing an experiment. So remember, observational study, not assigning treatments. You're just observing as they are. Experiment, you are randomly assigning treatments. So you have to have comparison of more than one group. Usually that's a control group with maybe not receiving a treatment or maybe receiving the previous accepted treatment. You have to have random assignment of treatments. That is key number 1. You have to have replication. Now, I was always confused on this. I always thought replication meant that I was going to repeat the study over and over again. And really what it means in this context is that we have a large sample size in each group. So my comparison is able to take place multiple times. And we have to have control of confounding variables when possible. And we talked about that confounding variable earlier in that study with the HIV patients, is that the confounding variable was the missed appointments. It had nothing to do with the explanatory variable of race that they were originally thinking. It had everything to do with that confounding variable of missed appointments. And luckily, those doctors were able to figure that out, and it was something they could work with their patients towards, work on that psychological variable of why they're missing visits and really follow up with their patients. Random assignment is performed in the same way we selected a sample. Random number generator, hat method. That's how you're going to randomly assign those treatments. Just always, guys, when you're asked to do that, to create a random sample or to randomize treatments and describe how that process would go, just be as specific as possible. You don't have to use fancy statistics words. Just explain it so that the reader could take that procedure and reproduce it, okay? And they could actually perform that randomization. Be as specific. You don't have to use fancy stats words. Use the words you would use explaining it to your friend. So yeah, the control group sometimes gets a placebo, or again, it could be the current accepted treatment. Let's say you're studying a new diabetes medicine. It would be totally unethical to give an existing diabetic patient a placebo that does nothing. So in that case, you would compare the new drug to the old drug, not to a placebo. The old drug in this case is the control group. All right, so again, you see that experimental design. You have your population. You put some in the treatment group. You put some in the control group, and then you compare those two groups to see how they responded to the treatments they received, be it the actual treatment or be it the control group. And blocking is an important part also of experimental design. Let's see. This slide is not wanting to work. Oh, there it went. So blocking is basically stratifying our sample, so separating our experiment into smaller groups and then performing many experiments within those groups, within those blocks, okay? Think of blocking as a physical block, not as like I'm blocking something from happening, even though that kind of is what you're doing. So of course, you know, this chapter just screams COVID vaccine efficiency. And for that particular example that we have, one of the experiments that we've seen is the Johnson & Johnson vaccine. And this graphic here is essentially showing their blocks. Okay, so they did an experimental study in the US. So among US patients, they gave some the placebo, some a vaccine. 72% effectiveness. Then they did the same experiment in South Africa. Different variant, different environmental factors, different mandated lockdowns, et cetera, et cetera. And in that particular group, it was only 57% effective. Now, combine those two blocks, and those two blocks gave us an overall effectiveness of 66%. There were probably multiple blocks created. Those are just the two we were really concerned about with the South African variant of COVID-19. So these two are two examples of blocks in which we separated our study into a smaller experiment in the US and a smaller experiment in Great Britain and a smaller experiment in South Africa, and worked through, put all those together to get our overall effectiveness. Some other words real quick. We're going to kind of go through these kind of quick. I want to get to our example. When either participants, researchers, or both are unaware of which treatment is present. This is generally necessary when doing an experiment. That's called blinding. So you could have single blinding where the researcher does know what treatment is being administered and the patient or the participant, the experimental units, does not. And then you could have double blind, which neither one of them know. Okay, so there's no prejudice or subconscious bias being administered by the researcher or by the patient. A matched pairs design is another special form of an experiment, and that is one where every participant will receive both treatments, or participants are paired together in homogeneous pairs. So I'm very, very like person B over here. We could be put together as a pair. One of us get treatment A, one of us get treatment B. Okay, or I could get treatment A and treatment B and see how just I responded. Okay, so that is a matched pairs where I receive both treatments. Yes, Sanders correct on that. Blocking is specifically having to do with creating our treatment groups. Almost like blocking is an experimental design, whereas stratified is our, like an observational study aspect of it. So kind of very similar things. One, blocking is an experimental design aspect, though. All right, so here is our example we're going to look at. A medical study team is aimed at studying the effects of melatonin on sleep quality. In order to test this substance, a researcher randomly assigns 40 participants to receive melatonin before sleep, while also randomly assigning 40 participants to receive a placebo. Sleep quality is measured each night for both groups. So part A, is this observational or experiment? What do y'all think? Observational or experiment? All right, looks like we are all on the same page. It is an experiment, and I know that you all know why. Because the melatonin and placebo were randomly assigned by the researcher. You also could even add in a note here that this means we can establish causation. From our results, we could establish that melatonin causes better sleep quality or does not cause better sleep quality, because those two treatments are randomly assigned. There's a control group, which is the placebo in this case, or maybe a sugar pill. What is a possible confounding variable in this study, and how could blocking be used to account for this? Lots of options on these types of questions. Just think, what is something that could affect someone's sleep quality other than melatonin? And there's lots of ways you could go about that. The one that I came up with was age. As people get older, their sleep patterns and abilities change. Therefore, blocks could be created off of age and randomly assign melatonin placebo within each group. Okay, I could take 55 and older, and then among the 55 and older, you take melatonin, you don't take melatonin, randomly assigned. Then I could take ages 30 to 55, do the same thing. You take melatonin, you don't take melatonin. And then I could take under 30 and do the same thing there. And I could look at what is the difference in sleep quality among age groups with melatonin versus not melatonin. Now, this probably requires me to have a bigger sample size, but it also makes the study stronger. You now have 3 miniature experiments you can put together as a whole, which is exactly what we're seeing in all the vaccine trials that we keep hearing about. Okay, and I'm seeing now environment, stress level, work hours, nightmares or night terrors. In my case, having young children that wake me up in the middle of the night all the time. All of those things are confounding variables that you would want to adjust for. Daily caffeine intake. I drank so much coffee yesterday and then I couldn't sleep. So definitely all great options. Just be able to explain how that variable is going to impact your study and impact the results. Which way is it more than likely going to sway things one way or the other? All right, same question. Part C, is it possible for this study to be done as a double-blind experiment? Yes or no? I'll put up a poll for that one as well. All right, y'all are on the right track here. Yes, it is possible here. Okay, the participant could not know whether they are taking a melatonin pill or a sugar pill, some sort of placebo. Also, the person measuring the sleep quality would not be aware which treatment was received. That would help reduce the placebo effect from the person, and also the person measuring sleep quality by subconsciously counting melatonin sleep as better sleep. If they're rating it on a scale of 1 to 10, they might subconsciously mark things down a little bit or whatever, okay? So that is possible in this case to be double blind. So basically what this process would look like, and this is not always on the AP Stats exam. I don't know that I've ever seen a question on, like this. How a double blind experiment would be carried out is all participants, okay, they're assigned a number, and then, they're given a treatment one way or the other. So the person giving them the pill doesn't really know. There is some statistical analyst in the background who knows that person 011, person 11, received the melatonin. Okay, they go home, they sleep, maybe a sleep study, they measure the quality of their sleep. The doctor just sees that person as 011. That's what they identify them as. They do not identify them as placebo or melatonin. They measure their sleep quality, then they give person 11, they give their data to the analyst, who then matches person 11 with one group or the other and puts their data in to then analyze it. So the doctor measuring sleep quality doesn't know. The person themselves don't know whether they received it or not. That's kind of how that would go in that blinding process. Okay, as always, our non-negotiables. And I also have some Quizlet decks to study. I'm going to put those in the Discord as soon as we're done here. Click through those Quizlet decks and study these vocab words. That's the best thing you can do on this particular chapter. So again, these non-negotiables are really what's helping us build our 5-hour cram finale. Every week, 5 main topics, and then we'll look at some previous AP exam questions using those non-negotiables. And I'll go through probably the past 10 or 15 years of exams and see from free responses, what did I miss and not put in the non-negotiables. And then we'll touch on those as well over the course of our 5-hour cram finale. So understand the golden rule of statistics, difference in experiments, observational studies. Be able to describe in your own words so that the reader could clearly proceed with that process, how to randomize treatments or randomly select individuals. It's the same thing, either HAT or the random number generator. Be able to identify treatments and experimental units in a given study. We didn't look at that a ton, but that it does show up a lot. Understand what a matched pairs experiment is and also why blinding is important. Effect, be able to answer questions on that. And then also different types of bias. Be able to look at a study as it is and see where bias might be introduced. Okay, and explain that. Again, I can't stress to you enough, don't hone in on these statistics words when you're trying to write up a response about bias, about how to randomize treatments or randomly select a sample. Write it out in your own words. Just make sure that things like mixing the numbers up, skipping the repeats on the random number generator are there. And if we're talking about bias, make sure you clarify which way that sample is going to more than likely bias things. Is it going to bias it, politically speaking, to the left or the right? Whatever the context is of the question. But be able just explain it. Don't think, is this response bias or non-response bias or voluntary response, all those terms. Don't stress yourself out over the terms themselves, but understand why they're important and how to apply them. Okay, and those Quizlet decks are great to look over those words because they could pop up on a multiple choice question. But in free response, just be able to write out in your own words what that bias looks like. That's one of the biggest advices I can give you on this chapter as well. Okay, and Discord, hop over there. I'm going to post these Quizlet links over there. It's going to take me a minute, so I have to find them on my phone, not my computer, but I'm going to put them there. And I would suggest going over those this week, also 2 or 3 weeks from now. Okay, just looking at those again. All right, any questions before we sign off? We'll click over here and look at the chat. Yes, so there are some things that it's impossible to blind the treatments. I'm trying to think of one as well. But there are options where it's not possible to do double blind. So yeah, hop over on the Discord. I'm going to look up an example for that as well for you, Sarah, and then we